5 for my half times 6 times 17 times the sine 135 close parentheses and then equals. And that got 36.1. This one right here, they wanted you to see if you understand law of sines. Law of sines is when you don't have a right triangle. 82 is not a right angle. Okay, so that means I've got sine of A over little a. This is little a right here. So sine of A, sine of 82 over little a, which is 34. This is a big A over little a right there. Okay, and then we would probably need, since we have little c right here, we're going to need to do big C. We're going to need to do sine of C over big C, little c, which is 27. So that's the one we're looking for. And that was this one right here. Sine of 82 over 34 equals the sine of C over 27. We don't have the little b or the big B. We don't have big B here, we don't have little b here, so we can't make a fraction out of that one. There's no pieces. We do have a little a and we do have big A, so that's one fraction we can make. And we do have little c, and we could put big C on top, and we could do our cross multiplying and solve. One thing you would have to do is you would need a -1 because you want the angle. They didn't ask you to solve it though, they just wanted you to find the right proportion. That's it. So that was, I don't know.
That was number 8.
That was 8. Okay, moving on, going to 9. Another one that's not a right triangle. And let's label what they gave us. They gave us little c right here. That's across from big C. They gave us little a. And then they gave us big B. We want to find little b. Okay, so they gave us 3 different letters, an A, a B, and a C. That means we cannot use law of sines. It means we got to use that law of cosines formula. And you don't have to memorize it, you just have to know that it's in 9.7. And you go look for it, and since we're looking for B, I'm going to use the B squared one. B squared equals A squared plus C squared minus 2 times A times C times the cosine of B. That's the formula. It's in your book. You can just go get it and write it down. So B squared we're going to leave. A is 45 squared. C, little c is 23 squared. Minus 2 times 45 times 23 times the cosine of 36. So that, and what's nice about these calculators is it can go right into the calculator. I can put the whole thing in. I can put 45, especially if I'm looking for the little b. I can put it 45 times, no wait, not 45 times, 45 squared. There's a little square button on this calculator. Plus 45 squared plus 23 squared minus 2 times 45 times 23 times cosine of 36. All of it goes straight in, just like that. And I get b squared equals 879.3. And then I just square root both sides. So I need to square root 879.3. That gives me 29.7 when you round it off. If it's 10th, yeah, nearest 10th, so I would go 29.7. Okay, so that's the one law of cosines you'll need on the test, and you just have to be able to plug it in, and be able to plug it into your calculator, which should work as well. All right, moving on. This one, there's always a ladder problem. Always going to be a ladder. It says it's a 20-foot ladder. Leans against the side of a house. So you've got your house, you've got your 20-foot ladder. So 20 feet. Okay, it says it's 3.5 feet from the base of the house. Okay, so that's the right triangle that you see right here. That's going to be a right angle. Use Pythagorean theorem to approximate how high the ladder reaches up the house. So from here to here is what we're trying to find out. So you're going to need to do your a squared, 3.5 squared, plus b squared, which is x squared, not the 20. The 20 is your hypotenuse. So 3.5 squared plus x squared equals 20 squared. So then you get your calculator back out again, 3.5 squared. You get 12.25. plus x squared equals 400. So 400 minus 12.25, which is 387.75. So x squared equals 387.75, and then you square root both sides. Square root of 387.75. And you get 19.7 if it's tenths. Oh, it says hundredths. So a hundredth is 19.69. 19.69 hundredths. That's how high it would go up the side of the wall. So it would be close to the 20 because it's not very far away from the wall. So that would be one of your Pythagorean theorem problems. Okay, so like I said, you don't have to write all that out, just to work with a little picture. That's all you need. Okay, moving on. This one was the challenge one. A lot of people still struggled on it, even though I had done once or twice already. So it is a struggle. They're telling you that the ladder's 20 feet. So the ladder here is 20 feet. The ladder here, if I change colors, this ladder is also 20 feet. The ladder doesn't change. The ladder is laying kind of flat, and then it's moving up. It's going up here. So there's just sliding the ladder from here up to here. And then we want to see how much farther this ladder would go from here to here. That's our x. How much farther would it go? So this is my red triangle, my right triangle. And in the problem, they tell you that let 12 minus 2x be the distance from the base of the ladder to the wall. So 12 minus 2x. The reason that is because this whole piece would have been 12 if you had done your Pythagorean theorem. That would have been 12. Because it says that this piece right here is 16. So if you had done 16 squared plus b squared equals 20 squared, you would have got 12 for that piece. So you have 12 and you're taking away 2x is this piece right here, 12 minus 2x. This whole side over here is 16 plus x, or we could put x plus 16. That's this whole side. So you got these two are the legs, and then the 20 is your hypotenuse. So you're going to do 12 minus 2x squared plus x plus 16 squared equals 20 squared. It's a squared plus b squared equals c squared. It's still your Pythagorean theorem. That doesn't change. So now you got to do FOIL. So 12 minus 2x times another 12 minus 2x. You get 12 times 12, you get 144. You get a negative 24x and another negative 24x. So you actually get negative 48x. And then negative 2x times negative 2x is a positive 4x squared. And then I'll bring down this plus. And then we need 2 of the x plus 16s. So you get x times x, you're going to get another x squared. X times 16 is 16x and another 16x, so you get 32x. And then 16 times 16 is 256. And that's going to equal 400. So we need to combine all our like terms and then see if we can solve that for x. So I'm going to combine my x squareds and get 5x squared. I'm going to combine my x's, negative 48x and positive 32x. It's going to give me a negative 16x. And then 144 combined with 256 is 400. Equals 400. So if I get it equal to 0, it's gonna cancel out those 400s. So you're gonna get 5x squared minus 16x equals 0. 5x squared minus 16x is 0, and then all you can factor out is an x. All you can take out of both of these, they both have an x. You'll be left with x minus 16. No, 5x minus 16 equals 0. So this is all your algebra 1. We just took out a factor here. This could be 0. If x is 0, then it doesn't matter what's in the parentheses because 0 times the parentheses will equal 0. But could you move the ladder a 0 amount? No, that's not going to happen. So that's not the geometry answer that we want. Okay? So we're going to want this fraction answer here. When you add 16 on both sides, you'll get 5x equals 16. And then you divide by 5, you're going to get x equals, and it's 3.2 when you round it, or when you divide it, you get 3.2. What I saw was that you could divide both of these by an x value. There's a common factor in there. So it's just a common factor that these two I took out to here. And I took away 1x here and I took away 1x there. The reason you have to do that is because there's an x squared. Now we could have solved it also if you had that. Let's say you had 5x squared minus 16x equals 0. You could have added 16x, I guess, and got 5x squared equals 16x. And then you could have divided by 5 on both sides. So you get x squared equals 16x over 5. You would have to divide by 5x. That way you get rid of that x as well. And you get rid of an x over here. So you'd still get the same answer, 3.2. It's just better if you take out a GCF here. It's better for GCF. If you got an x squared, you want 0 because that's your zero product property. That means then you could find out that whatever makes these equal 0 is going to be one of my answers. Yeah. All right, let's go. Some of them are going to go pretty quick here. I think that was one of the long ones. Let's move to the next one here. Okay, you're painting or planting a garden in the shape of an equilateral triangle. You want to find the area of the garden to determine it. So this time they're using the old formula. 1/2 times base times height. So this is the base. The reason I say this is the base is because there's a right angle. So if that's the base, then this has to be your height. So you've got a base times a height. So we know the base is 4, but we don't know is the height. So you've got choices. You could use SOHCAHTOA to solve for the height. Okay, that's kind of a short way you can do it because you should know that in an equilateral triangle, these are all 60s, right? So these are both 30s. So that means that you'd have a 30, 60, 90, or that you could use SOHCAHTOA from this 60-degree angle. This little piece right here has got to be a 2 because both of them together makes the 4. So this piece is 2, this piece is 4. You could use the SOHCAHTOA by doing opposite over hypotenuse. So you could do sine of 60 equals the opposite x over the hypotenuse of 4. That's the opposite over hypotenuse. That is going to give you a decimal when you multiply by 4 on both sides. If you cancel it out, x is going to equal a decimal. And I don't know that the answer is going to take the decimal. It might. 4 times the sine of 60. I mean, it should take the decimal, even though it is rounded. You get 3.46. So that would be your height. So your base would be 4. Your height would be 3.46. Probably not the fastest way to do it because they're trying to help you see that this is a 30, 60, 90 triangle. And there was a whole section based on those two triangles, 30, 60, 90s and 45, 45, 90s. So I think what they're hoping here is that you'll use the formula hypotenuse equals the short leg times 2 and the long leg equals the short leg times radical 3 in this one. And what we're looking for is this long leg right here, which is my height. So all I need to do is take my short leg,